we'll start the recording. Okay. So we are getting quite significant group. It's going to be very interesting to discuss all these kind of issues related to scanners and point clouds. Okay, I see that here we have yeah, Mitko and Johnson is here. Okay, very good. And Bing Hao, excellent. Yes, we have the teachers as well. Good to see you, Johnson and Bing Hao. Yes. So I will start slowly explaining what the idea of these meetings are. Actually, all of you, hi Bing Hao, all of you somehow are doing something with point clouds or with scanning and processing point clouds or developing some algorithms that are again related to point clouds. And when we discussing individually with all of you, somehow, yeah, I realized that the questions that we're discussing, somehow they repeat through the different students and researchers. So at a certain moment I was thinking probably it's good to get together and have these meetings twice per week and just exchange information. It's very informal. I have to warn you. The idea is not to be kind of strict presentation. You don't need to feel like PhD students that have to prepare a presentation or researchers that have to prepare a presentation and, to be under stress. No, the point is when you have some kind of problem, just to put few slides to explain what you're doing and where you got stuck. And we all together to discuss and to see whether we can find a better solution. Also, when the point is about scanners, with Muran, we discussed quite a lot of things related to accuracy and types of scanners. And actually, Johnson and Binghao, they are really kind of the experts in this area. So instead of discussing with me, and it's exactly better to have somebody that immediately can give you information and immediately can advise you on something. Mitko and Abdul, Abdul joined as well. Oh, Josephat is joining from Mexico. Okay. Wow. Hi, Josephat. Some kind of noise is coming from there. Josephat, do you hear us? And Sadman is also here. Very good. Hi, guys. So, yeah, because apparently everybody is here, probably it's good to make really kind of very short round with few sentences to present yourself, just to know who is who. And after that, Josephat, welcome. What time is in Mexico? You're muted.
1 a.m. in the morning.
Wow.
It's okay. Good morning.
I was thinking that you'll join only on the meetings that are later at 2 o'clock. Okay, but good. So the point is to be informal. The point is to discuss things and to exchange information. In addition to the really kind of experts with as teachers that have something related to sensors and using sensors, we have also experts that are doing development, processing of data. So Mitko is one of them, Abdul is one of them. And we also have quite a few projects on which some of you are going to work together. For example, Max is going to work on projects, and yeah, you switch off the camera, so I can't see where is we lost somebody. Oh no, Jiang. How do you prefer to call you, Jiang?
Just call me Kill him.
Kill
That's
him.
fine.
Okay.
Yep.
Okay.
Yep, thank you.
Okay.
Yeah.
Okay. Good. So let's start making a very small circle with the introduction. I'm Sisi Zlotanova. I'm in the group of GRIT in Built Environment, Faculty of Arts, Design and Architecture at this moment. And we're doing quite a lot of stuff related to 3D and point clouds, voxels, and yeah, it's really my pleasure to be here and to see all of you and yeah, start this series of meetings. So let's first invite the teachers. Bing Hao, could you say something about yourself? Somehow, yeah. We hear you, but I don't see you. Probably it's only me, but
I'm currently in
oh, okay.
but I'm in School of School of Minerals and Resources Engineering. I was I think Sisi has the same background.
Yeah, we don't hear you very well, but okay.
I'm working on finding myself originally doing production, especially in
Okay, when you find place, probably you can say something more. Johnson?
it's very noisy.
Yeah. Johnson, would you like to say a few words?
Sure. Hi, everyone.
yourself?
Yeah, this is Johnson Shen. I'm a city lecturer from School of Civil and Environmental Engineering in another faculty of engineering. So yeah, we're doing a lot of work for like mobile mapping using laser scanners, LiDARs for outdoor, indoor environments. And one of the projects we have completed with my industry partner is for like real-time 3D mapping using drone and LiDAR. Yeah, so that's one of the industry projects. So I think here it's good to see everyone, and so I have some ongoing collaboration with CC, and also we have joint supervised PhD students Han from Shanghai here, and also for today's meeting I invite one of my PhD students Mohamed to join us, so he can explain about his project later on. Yeah.
Okay.
Good to see you.
So Jack, I see you. Say something about yourself.
Yeah, I help Sisi with the manage the grid lab, and my background's in architecture going back to the 90s, and I really enjoyed using traditional CAD software and geographic information systems, but with the gravity and the excitement of point clouds, I've been doing quite a few projects using point clouds and LiDAR, so some heritage work in Sydney and some heritage documentation work in Japan, scanning the architecture of the work of an architect called Shoei. We'll be exhibiting that in November.
Mitko, could you say something about yourself? Few sentences. Put your camera on.
Hi everyone, Mitko. I'm postdoc in grid group, the one that Sisi is managing and leading. What I'm doing is maybe a bit broad, but related to point clouds, I can say I'm doing a lot of voxelizations, not only using point clouds, but from using 3D models and so on, and anything related to voxelization and voxels. If you have something related to this, you can email me. We can work together on it. And apart from this, I like to use databases, do some simulations, and that's pretty much it. Thank
Okay,
you.
thanks, Mitko. Abdul, do you
Hi,
have
everyone.
good connection to say something?
Yeah, can you hear me?
Yeah,
Okay.
we can. We don't see you.
Oh, yeah, my camera is on. But,
Oh,
well,
okay.
anyway, yeah, so I'm Abdul as well. I'm a grid team member. So I'm not that much expert in Pointcloud specifically, but I've been working with Pointcloud for quite some time now, mostly dealing with transforming Pointcloud to BIM model. So something something like scan to BIM. So I have experience with few software like Cloud Compare and these kind of tools that can deal with Pointcloud. In Seagull as well, some libraries, C++ libraries. But otherwise, my expertise is mainly in indoor modeling, 3D indoor modeling, and indoor navigation. And now more recently, digital twin and integration of BIM and GIS.
Exactly. Cynthia, welcome. Could you say something about yourself? We are presenting now the teachers within our group.
Oh, okay. Hello, hi everyone. Yeah. Sorry for coming a bit late. I was on phone call. Yeah.
No problem.
Okay. I'm Cynthia. I think most of you know me from construction management. My research interest is on has been on building information modeling applications in construction management. Just recently, I got some good sciential PhD student working on the Pointcloud projects. So it's just at the beginning of my exploration on Pointcloud. Yeah. So I'm here to learn. Yeah. Okay.
Everybody is here to learn, Cynthia. Okay, I don't see other teachers from the university, so probably we can start.
Sorry, Cici, can I introduce Volga?
Yeah, yes, sure.
Volga, please introduce yourself.
Yes, okay, Boga.
I think you are on mute.
Volga, I can't hear you.
No, he's not on mute, but we cannot hear him.
No,
Yeah, he's not on mute. We cannot hear you,
problem
sorry.
with the connection, yeah.
Maybe the configuration. Microphone.
Yes, that's probably he needs to switch.
Because the camera is also not working, huh?
Hello, can everyone hear me?
Yeah, let's see.
Yeah, now it's better.
Fine.
I think it's working now.
Yeah, go ahead. No, he disappeared completely. Yeah. Okay, he'll come later.
Yeah, what is interesting is that Josephat and Han are in the same room.
Oh yeah.
It's the same room.
So, okay, while Boga is trying to sort out the connection, let's start with short introduction of all the researchers. And I would like to start with Harshit because he has to go for a vaccination, right, Harshit?
Yes. Thank you,
Okay,
Sufi.
yeah.
Hi, everyone. Myself, Harshit. I am a PhD research scholar at Indian Institute of Technology, Roorkee in India. And my topic of research is basically implementation of photogrammetric point clouds for 3D GIS modeling. So basically what I'm trying to do, we have done a lot of work in photogrammetric point clouds. So I will be trying to exactly use those photogrammetric point clouds and what are the improvements that could be made and how it could be implemented for a 3D GIS model. So basically, in short, this is what I'm trying to do. Thank you.
Thank you, Harshit. Good that you manage it. Now let's go to our people from very far away. Joseph, but I think you're really from very far away, almost from the other side of the world. Say something about yourself, please.
Hi everybody. Yes, I'm Joseph Pat. For me, you are so far away, so don't worry, it's the same. But okay, I'm a PhD student. The topic I'm working with is again processing point clouds, but with the aims of using or creating spatial grammars. It's a confused topic, but okay, it's kind of getting a human-oriented way of processing point clouds. But okay, that's something I'm working on. But I like to describe myself as a technology guy who tries to integrate multiple technologies. Something that is kind of interesting, I could say, is that I work a lot with the web. That means JavaScript. That means WebGL. I've been working with X3 DOM, CGS, and all these web technologies, but also I try to integrate a lot of this database processing. So that means PG Point Cloud, PostGIS, PG something, PDAL. So I mean, I like really a lot this integration of web, database, and processing, and so that's mostly what I do, what I like, what I love.
Okay, thank you very much, Joseph.
Welcome.
Now, who is coming close by? So China. I don't know who is closer, Han or Mudan. Mudan, go ahead. Say something about your research and who you are.
Hi, I'm Mudan. I'm a PhD student from the construction management. Now, my research topic is on the on developing a streamlined quality tracking process for the prefabricated wall panels on the construction site. So now I'm doing some segmentation process on the point cloud data collected from the construction site. Now I'm exploring the segmentation parameters, how these parameters will influence the segmentation results. That's what I'm doing now.
Okay. Excellent. Thank you, Mudan. Han?
Thank you.
Yes. Hi everyone. I'm Han Xu and I come from China like Mudan, and I'm a PhD student who is in his first year under the supervision of Cynthia, Johnson, and Cici. And what I'm going to do is to include the tree models in the city models for the analysis of carbon emissions. I'm still in the initial stage of my research, and it's my honor and my pleasure to study with you in such an excellent team. Thank you.
Thank you, Han. After that, probably go to Sophia. Could you say something about yourself?
Hello, Cici. Hi, everyone. My name is Sophia. I come from Indonesia, and I just enrolled in term 2, so I'm very new here, and I'm also new in topics of point clouds, and my research topic is about documenting urban heritage, exploring heritage values, and try to document it by using LiDAR and photography to make a 3D visualization of heritage cities. Thank you very much.
Thank you, Sophia. Nina, I will leave you for later because anyhow you are going to say something about yourself when you start the presentation. So let's go then to, okay, Sadman, you put your camera on, good.
Hey guys, I'm Sadman Yusuf. Very nice to meet you guys. My background is in urban and regional planning, and I am doing my master's by research. My thesis is in examination right now, so pray for me. But my research was on processing point cloud of a forest profile using Voxel to make a digitized map to know where the highest accumulation of vegetation is present at certain strata of forest profile. So I'm actually doing my master's and completed it. I hopefully completed it. So I'm still in the learning process, and I'm actually here to learn. And all of you guys are my teachers at the moment. So yeah, nice to meet you guys.
Okay, and I see that Boga is managed to connect. Would you like to introduce yourself, Boga? Or still some issues with the connection? Somehow it's still not quite good.
Yeah, he wrote in the chat that still
Okay.
cannot reach us.
Okay, good. So let's continue with the people that are here at the university. Who is going to start? Jing?
Yeah, I'm here.
Okay,
Hi.
say something about yourself.
Hi, thank you, Cici. Hello, everyone. I'm Jean. My background is landscape design. Currently, I'm trying to employ the generative parametric model to explore how to balance the human well-being and the stormwater management within the limited urban green space. So you can see, although currently it's already my third year, but I'm still quite new in plot point. So thank you for Cici giving me the opportunity to learn at here. Thank you.
Okay, we have Mohamed. Boga, you manage. Okay, go ahead.
Yeah, thank you, and hi everyone. First of all, I'm happy that I'm here and introduced to all of you. That's my pleasure. I'm from construction management discipline, School of Civil Environmental Engineering. My research topic is also related to construction progress monitoring. We are using Pointcloud and associated with like using different technology like LiDAR Pointcloud. We use handheld LiDAR mobile mapping system to collect the Pointcloud. Then we convert that one to we are using like scan to beam method to measure the construction progress monitoring, progress of a construction work. And that system could be used for different structure elements that could be permanent structure elements or could be temporary structure elements. Yeah.
Okay, excellent. Thank you very much. So you'll have some interesting discussion with Mudana, I believe, because she is also working in this area. Okay, so
Hello.
after that, Boga.
Hello, can you hear me?
Yes, we can hear
Oh,
you.
okay, cool. You can hear me now. Okay. Hello everyone. This is Berg, and
Berg,
I'm
how do
currently.
you pronounce your name? Would you say?
You can pronounce it as Borger.
Burger. Okay.
Yeah.
Burger.
That's correct. Thank you. I'm a postdoc fellow at the mining school. Actually, I received my PhD degree from the computer science and engineering. So my research interest is focusing on identifying objects from the point cloud. Currently, I'm working on identifying the rock bolt in the tunnel. So yeah, we use some LiDAR to collect the information from the tunnel, and we want to identify the objects like the rock bolts. And in the future, we may want to identify other things. What I'm doing is using the deep learning model. So that is to train a model and use it to detect the objects. So yeah.
Okay, very good, excellent. So we have also Max and Kilam. Max, could you introduce yourself?
Yes. Hi, so my name's Max. I'm an undergraduate student at UNSW. I'm in my third year studying mechatronic engineering and advanced physics. Yeah, I'm very interested in sort of 3D design and manufacturing. I'm also a casual student assistant at the Michael Crouch Innovation Center at UNSW. So I run sort of the makerspace workshop where we do we run inductions and we do a lot of 3D design as well and run inductions in CAD and amongst other things. And so this project I just saw as part of the Taste of Research program that UNSW offers, and I thought it was quite interesting. Yeah.
Okay, so the project that Max is mentioning is about dynamic, modeling of dynamic changes in the environment or monitoring people and movement of people. And this is a project that we have with one company, and it just starts. And with the meetings, probably Max and Kilam are going to give presentation and tell you more about the project. So Kilam, could you introduce also yourself?
Yep. So can anyone hear me? You guys hear me? Yep. So I'm Jiang. So you guys can call me Kilam as well. So I'm also a undergraduate student, third year, doing mechatronics and computer science engineering. I'm also the candidate for Taste of Research. So I have also some exposure to LiDAR in my mechatronics project. So I believe maybe I could refresh myself by doing this project again. So I'm also glad to be invited into this meeting. So hopefully I can gain the most out of it in this meeting. Yep. Thank you, everyone.
Thank you. So I think we have everybody. If I miss somebody, I don't think. Everybody presented himself. So again, these meetings are exactly to help. They're informal. We can discuss any kind of things from different kind of scanners, software tools, or some programming and development issues. Doesn't matter. So everything that you think, or some research questions, or some kind of approaches, how you consider to collect data for certain applications. So it doesn't matter. Everything that is related to LiDAR or photogrammetry collection of point clouds and after that processing and building 3D models, this can be discussed within this group. I know that many of you don't have programming experience, so they're looking for tools and hoping that some tools are going to help them to achieve the goal of their research. So some of you are doing even comparison between different open source software packages like Harshit, and he already completed some study and he's going to give us presentation next time. So everything that somehow you want to put on the table for discussion, it's here. Even ideas. If you have within your research, you have got some kind of idea and you don't know whether you can go forward with it, you just can put it here and discuss it, and we'll find a way to go further. As I said, you see, there are so many teachers with different expertise here, and also so many PhD students with different topics, but the topics are overlapping. And I expect that we'll have some interesting discussions. For example, Sophia and Jack are somehow working into architectural recording. Mudan and Mohamed, I think, they're also working in the area of the construction and monitoring construction works. Harshit, Josephat, Mitko, all of them are processing data, and actually Max and Kilam, they're also going to develop software and process data. Sadman, Han, and Nina, they're working with vegetation, which is also kind of overlapping area, so also quite interesting. So before Sadman goes, probably he can also give us a presentation what he did within his research. So I expect to be really kind of interesting. And because it's not formal, you can stop and ask questions without any hesitations, you know? It's, even if we have some small presentations, the point is just to explain what the person is doing and what kind of questions are there. It's not a formal presentation. And again, at a certain moment, we'll see probably we'll ask some of the teachers to give us some information about sensors or about technologies or about algorithms. We'll see how this goes. So everything is open. And the point is, as I said, to help each other to go further with the research. And I hope also very much that collaborating with each other, it will lead also to probably some nice publications. You can get together and prepare a paper together instead of trying to prepare a paper by yourself. Okay, so do you want to say something, some questions or something? As it was mentioned in the mail, we plan to have 2 meetings, the second week and the last week of the month. If you're not able to attend, don't worry. As you see, we are recording these sessions. It is going to be about 1 hour. In the second week, it will start at this time, 4 o'clock. In the last week of the month, we'll start a little bit early, 2 o'clock, because of Josephat, not to keep him awake during the night. So again, if you somehow cannot attend, don't worry about this. These recordings will be shared. And if there's no any questions or nobody wants to say something, we can start with Nina. And she has prepared something for you. I'm curious what she has prepared. No questions, no answer, no any notes, nothing? Okay.
Yeah, I can say a few words before Nina starts.
Go ahead.
We heard that all of you are kind of specialized in one part of point clouds, and you cannot kind of deal with all of them. And I think it's good if you kind of collect for each person the main like areas that you are working in, that you are interested in, and we can kind of organize all people in one tree or like document to see the skills, to match them and to see what you're interested, and maybe we can start working together easily since 2 of you or 3 of you will devote some time in that particular area very soon. And I think it is good if we can organize. We heard, let's say, from Josephat that he's working with databases, web, and so on. If we kind of organize based on our interests and our skills, just put few words, keywords that you are interested in. If we kind of organize all of us, we can kind of know our interests, and if we have some questions, we can easily refer to that person, because currently I cannot kind of pick up who said what. Yeah.
Excellent suggestion. Yeah, excellent suggestion. Yeah.
Just I'm not sure who is gonna deal with this, but I think if we can send an email to a person, or maybe even me, I can.
Who wants to collect this? Sadman, would you like to collect this information from everybody?
Yeah, 2-3 words. Yeah, something related to point cloud.
We'll do that. Yeah.
Yeah. Okay. Excellent. Yeah. Okay.
Just send.
You can make some kind of table even with some. Yeah.
All right. No worries. Yeah, I got this.
Yeah.
Okay.
Perfect.
Thank you.
Okay, Nina, you have.
Somebody has other nice suggestions? No. Okay. Nina, finally, you.
Okay, thank you, Cici. Hello, everyone. So I'm Nina, and I'm one of Cici's PhD students, and I'm currently in Vienna. And my research topic is on automated modeling of heathland vegetation in the Blue Mountains. And I'm not a point cloud expert, but I'd like to become a point cloud expert by the end of my PhD degree. So today I'm going to run through a presentation, a very informal presentation that I prepared, and I'm going to quickly go over my research topic, my methodology, what software I'm using, and what my current objectives are at the moment, and then I'll quickly talk about what I'm looking at doing in the near future. So I'll just share my screen. Okay.
Switch off the camera, or at least the mics, mute the mics.
Okay. Can you guys see my screen now?
Yep, thanks.
Yeah.
It's in
Yeah,
the...
we can see.
Okay. So automated 3D modeling of heathland in the Blue Mountains. So heathland are they're small shrubs, shrubland and male, and what makes them different in Australia compared to other vegetation is that the live heathland vegetation is very flammable, unlike other vegetation types where the dead fuel on the ground is flammable. With heathland, it's the live vegetation that's flammable. And they're generally sort of shrubs. They're up to between 0.5 meter to 2 meters high, and in between heathlands you find mallee trees. Mallee trees are a type of eucalyptus tree, and the mallees are from 5 meters, around 5 meters, and sometimes they can grow higher. And occasionally you can find sparse trees in the heathland environment. The heathland environment, they're actually patchy, and it's difficult to identify them with satellites, although the satellite resolutions are better now. Generally, they're difficult to identify, and it's also difficult to identify the boundary between heathland and woodland. And heathland in the Blue Mountains make up roughly less than 2% of the Blue Mountains area, but they are quite flammable because of their vegetation pattern. So they've got a ladder type pattern where you have the vegetation being shrubland, which is like 0.5 to 2 meters, and then it goes from that to 5 meters, and then it goes and when it joins the bushland and the woodland, it can cause fire from ground surface to crown level. So that's what makes that's another factor that makes heathland very dangerous and important to map. So went through that. So the problem that we currently have is that we've got the the National Vegetation Information System, and the National Information, the NVIS map has all the vegetation across Australia mapped, but with heathlands, it's a little bit difficult. They're not mapped correctly, or if they are mapped, they've been mapped in 2D, or the resolution is really coarse or undefined. And the idea of this research is to make heathland and map them in 3D. So important vegetation parameters such as canopy height, cover, the sub-canopy height and cover can be identified through the 3D model. And also we can have these sparse trees and the males that you can't identify with satellite to be identified in the heathland environment. And the methodology that I'm going to be using point clouds, and I'm going to use a voxel method. And I'm going to set a voxel connectivity where voxels that are filled with point cloud are all connected together, and voxels that are empty are disconnected. So you have a connectivity for all of the voxels that are connected, and you don't need to have the exact model of the vegetation.
So
Just
Nina,
the connectivity.
probably, sorry that I'm interrupting, but because it's not that formal, as I said, you can expect that you can be interrupted. I just wanted to ask you, probably not everybody knows what voxel is. Could you explain a little bit what voxel is?
Yeah,
and
voxel,
why do you want to use voxels instead of processing the point clouds directly?
yeah, so with the voxels, voxels are generally cubic, and what makes it easier using the voxels rather than the point clouds is that it reduces size. So the processing is going to be quicker. There's going to be less point clouds. With the point clouds, there's going to be a lot of point clouds, but this way there's going to be less. And then it's also structured a bit more. Point clouds are unstructured, so voxels are much more structured. And have I explained it properly, Cici?
Yeah, sure. Thank you. Yeah.
And this way, the memory space that I use, the processing time is just going to be quicker. And generally, we just want the connectivity of the vegetation. So like if you've got three shrubs next to one another, this is just a schematic version. You would have like a connectivity like this, and this would be made up of different voxels, but it would represent one connectivity. And when there's no vegetation, then there wouldn't be a field voxel. So my methodology is to have LiDAR point clouds, and then I'm gonna normalize the height. And after normalizing the height, I'm gonna create the digital terrain model and the digital surface model. And from the digital terrain and digital surface model, I'm gonna have the canopy height model. And from the canopy height model, it's gonna be the initial classification of the vegetation height, then voxelization, and after voxelization, I'm gonna make the data binary. And the reason that I'm gonna make it binary is because I'm gonna have the processing time is gonna be quicker, and I won't be using much memory space. And then I'm going to do the automated vertical and horizontal segmentation, and I'm going to identify a rule-defined vegetation classification based on maximum vegetation height. And then from the number of vegetation layers, I'm going to identify the I was looking at putting in a vegetation growth model for visualization, but I might not be doing that. But at the end, I'm going to have a 3D Heathland model, an automated 3D Heathland model. So this might not happen, but yeah, up to debate. So my current objectives and what I'm currently doing or have done partially was the normalization of the height. This was done. Identifying the digital terrain model. So the digital terrain model is already produced, but one at 1 meter grid size and the other one at 50 centimeters. I've done the 1 meter, but with the 50 centimeter one, there's a problem with the software, and the software isn't producing the 50 centimeter one. And I've forwarded an email to have it investigated, but this is not being produced at the moment. Remove the digital terrain model from the data set. Remove man-made objects such as buildings and power lines, so I can only have the vegetation left. Classify live and dead vegetation. Then stratify live vegetation such as shrubs, male, and trees that are above 12 meters. And then after that, identify the live male vegetation. So to do this, I've been using Opals. Opals is designed by the Technical University of Vienna, and it's a scientific software, and it's used for point cloud processing. And with Opals, you import your point clouds and you convert it to ODM. And once you convert it to ODM, you can either continue working with it in 3D, or you can convert it to 2D. So there are modules that are both 2D and 3D related, and there are modules that are specific to just 2D, and there are modules that are specific to 3D. So
what is ODM, Nina? ODM?
I'm not too sure, but it's they don't use LAS, they convert LAS to ODM.
Oh, this is a file format.
Yeah, it's a file format. So they don't use LAS, they always use ODM. So you always have to convert it to ODM before you start using the LAS data.
Do you have converter?
Yeah, it does it automatically. Yeah.
Oh, it does it automatically.
So you've got a module called Opals import, and you import the LAS file, and then or the LAS file, either or, and you convert it to an ODM. So you set your in file, which is your LAS file, and your output file, which would be your ODM. And then from there on, you always import your ODM file to do any of the modules.
Is it easy to install and to work with it?
It is easy to install and work with, and you can also set it up with PyCharm. So I was using it separately before, but now I'm starting to use it with PyCharm, and you can write all of the commands in PyCharm and do extra commands outside of Opals when you want to. So, yeah.
Yeah. So tell us what this software can do and whether it's going to be useful for somebody else. It can be downloaded free. It's free software. Yeah.
And I think the demo version, it can be downloaded for free, and I think if you want the non-demo version, I think it's for free for all research students, master and PhD, you just have to fill out a form, and they give you access to the non-demo version for free. That's my understanding. And
Okay, that's
yeah,
good. Yeah.
and it's quite easy to use. Yeah, so what I've currently done is using Opals. I've created my digital surface model, my digital terrain model, and my normalized digital surface model. So the digital surface model, these are all, I've converted the ODM into a grid format. And this was fairly easy. It's easy to create the digital surface model. The digital surface model is all of the echo points that are above ground. The digital terrain model was using the moving plane interpolation, and it's all of the using the ground surface echo points. And the normalized digital surface model is the digital surface model subtracted by the digital terrain model. And what you can do when you're working with Opals is you can, when you're working in 3D, you can add all of these as attributes to your ODM if you want, and then whenever you want, you can do classifications and filtering. So that's available with the 3D method of working with Opals. So after creating the
Just another question, Nina, about the DTM. So it can be used for any kind of data sets, right? It's not only for when you have point clouds of vegetation, but it could be a point cloud of a city with houses and mixed vegetation houses, right? Yeah. Okay.
Yeah, it can. Yeah, the digital terrain model can be produced for for any type of, I guess, landscape. Yeah.
Yeah. Okay.
And I think especially in Vienna or in Austria, it's very there's a lot of slope, and it's highly vegetated. So I think it's they use it a lot, and yeah, they've produced really good DTMs.
Yes, that's true. They're very much focused on producing good DTMs. Yeah, that's true.
So after creating that, the next step that I followed was to create the echo ratio, and I used what the echo ratio is used for is to identify flat surface, so to identify point clouds on a flat surface and point clouds that are how can I say, such as trees. In trees, it's not flat, so you've got point clouds that are beneath the tree. So what the echo ratio does is it looks at the 2D mode and the 3D mode. So in a spherical mode, it looks at all of the point clouds in a 2D mode, in a 3D mode. And in a cylinder, it looks at all of the point clouds in a 3D. And what it does is it identifies the flat surfaces and not flat surfaces. And based on this, you can classify ground vegetation, or also such as roofs from trees, and it's a method used for classification of vegetation from non-vegetation and above ground vegetation from ground vegetation.
Right. So this is one of the functions that this software provides, right?
Yep.
Yeah.
it's got a slope adaptive extension for roofs that are inclined like this, and it can eliminate them as well from the output.
Okay. So, and you mentioned that you can run this function also from PyCharm.
Yep.
Okay. Yeah. So, looks exactly as a useful tool also for Han, I think, to investigate.
And once you do this, you have the echo ratios of everything that's in your point cloud, and then you can put in a filter of point clouds below a certain echo ratio and point clouds above a certain echo ratio. So the echo ratio for vegetation, not flat vegetation like grass, but elevated vegetation like trees and shrubs, would be generally around 50% or less than 75%. And anything that's flat would have generally an echo ratio of 80 and above. So the grassland is 100%. Roofs are around 100%. Sometimes they might be around 80. So using the echo ratio, I filtered out the vegetation, and I set an echo ratio of 75% and below. And I got, this is my strip, and anything that's green here is vegetation, and anything that isn't green is non-vegetation, obviously. And I focused on this red area here, and this is in the 3D mode. And you can see that I've extracted all of the vegetation from the non-vegetation, and I've added the echo ratio as an attribute to my ODM file, and I can do further analysis on it, for example, extracting buildings if I want. But what I did notice is, I wanted to point on this, there's one power line here, and the echo ratio didn't extract the power line, and I think I need to do another, I need to use another module to get rid of the power line. I think I need to use the normalization module to get rid of that. I don't think the echo ratio does that. But
sorry. Can I ask something about it? This echo ratio.
Yeah.
For your example, I assume you are using airborne laser scanning. So
yes.
Have you tried with something which is not airborne laser scanning?
No, but it should be the same, shouldn't it?
Okay. I'm not sure. I mean, it looks like, but I'm not sure how well it works. That's why I'm asking. But okay, it's fine.
The echo ratio would be the same for terrestrial laser scanning or for ALS. It should be the same.
Okay.
That's a good question, actually. Because when you have terrestrial, what is going to happen with the facades? Because if you go to the previous slide.
Yeah, you don't have the
vertical windows. Yeah.
Yeah, I know.
Yeah, because they consider that it's vertical.
Yeah.
But with terrestrial, you'll get a lot of points on the facade, so
and not points in the roofs also.
Yeah.
Yeah, and of course, you'll not have points on the roof.
I'm not too sure then, but with the vegetation, it should be the same, CC. I wouldn't know how with the buildings it would be, but with vegetation, you would have the same result. Yeah.
Could be. Yeah. Because they'll be still again scattered. But whether you can distinguish between vegetation and tree and buildings is going to be not that clear.
but if you want, I can forward this question to Norbert's team and yeah, get back to you on that. If
yeah,
you guys are
okay,
interested.
yeah, it's interesting to know.
So this is my output, which is the vegetation, and I still have a power line here. And I'll discuss that sort of towards the end, what I'm going to consider doing to get rid of that power line. So after getting the vegetation, I should also say the module that I'm using here in Opals is the module Opals View. And what Opals View does is it displays everything in 3D. It's for 3D analysis of the point clouds. And after creating that, I did a echo ratio of all vegetations below 2 meters and all vegetations above 2 meters. And these are the, I've attached a screenshot of what they look like in 3D sort of view. And that's the overall sort of output. I'll need to produce another output, which is vegetation. I'll need to differentiate between the vegetation above 2 meters. I need to separate that between male and really high trees. So that I haven't done. So what I didn't mention is that my data set is of a bushfire region. So another step that I did was get the NDVI of the region. This area is actually water, so there's no data, but I can use a module in Opals to fill this, but the morph module to fill this, but I haven't done that. But anything red, anything yellow here is live vegetation, and anything that isn't yellow is non-vegetation. I did the NDVI in QGIS because I was having problems in doing it in Opals, but I want to do it in Opals and add this as an attribute to my ODM file. So I can subtract the, I can identify all of the live male vegetation and all of the live shrub vegetation from the dead ones. But this I haven't done at the moment. So I only have a 2D output. I don't have a 3D output.
Mm-hmm.
And the last step that I've done right now is voxelization. So this is on the right is the voxelization of the whole data, all of the vegetation above ground. I've got a voxel size of 0.4 and a 0.8 of the vegetations. And on the left, I've got a voxel model of all the vegetation below 2 meters at 0.8 voxel size. The screenshots aren't the best because it's with Open3D, and I'm not too familiar with how to navigate with Open3D, so it's something that I need to work on. But yeah, so where I'm heading to after this is I need to add my NDVI to my ODM, and I need to identify all of the live vegetation, all from the dead vegetation, And I also need to use the Opals normalization module and the eigenvalues to subtract the power lines from my point clouds, and I think they're the when I go here, the power line, the buildings have been removed, but the power lines, I just need to use a different module for that. And I need to add the NDVI to my ODM and stratify all of the high trees and the mallee trees and identify the live mallee vegetation. So that's where I am right now.
Mm. And Nina, when you you finish. Okay, thank you. I have a question. When you voxelize, how much, what is the reduction of point clouds? How dense was your point cloud at the beginning, and after that, with the different resolution that you have, how much did you reduce the data?
I haven't analyzed that. How would I have to analyze that, Cece? Would I have to analyze that based on the size of the output, or
yeah, you should be able to know how many points is in the point cloud.
Yeah, the number of points per square meter would be around 120 points per square meter. But I haven't checked with my voxels. I haven't analyzed the voxels to see how much it's been reduced.
And how did you, what kind of tool did you use to do the voxelization?
I used the code in Jupyter, but I'm going to shift everything into PyCharm. And I used Open3D for visualization.
So probably it's nice if you put all these tools that you have used on one slide, so everybody knows. Could you tell us something about the voxelization tool that you use?
It's not a tool, it's a code.
A library.
Sorry?
A library?
Yes. Yes, I got the code from Mitko, and I used that for the voxelization.
Okay. And what can you tell us about it? How big data can it process, and how quick does it go?
It's very quick. So the voxelization didn't even take 30 seconds. It was very quick. With running the point clouds, it took a long time to sort of open it. So I had to reduce the size of the region that I was working on. So initially my region was that big. I reduced it to a smaller size in order to be able to view the 3D point clouds in Opals. And generally when I want to open it in 3D, it takes maybe a minute for it to load. But with the voxelization, it didn't even take, it was just, really quick.
Okay, so can you process the whole patch when it is voxelized, or you didn't voxelize it yet?
The whole area? No, I haven't done the whole area. No.
Okay. Okay, so if we go back to these Opals, what can you tell us? What are the functions are in Opals?
So if I go here, so this is one of the functions in Opals, which is for power line extractions of ALS data. And it says ALS. So, yeah. So you can extract the power lines using the normalization and the eigenvalue. It gives you examples on how to use it. There are, down the bottom, there are papers that have been written that you can refer to. But when you go in the module list, so you got add info here. Add info is a 3D and 2D module. Algebra, you can do statistical and mathematical operations with algebra, and this is for 2D. Bounds, I guess it's 2D. I haven't used it. You got cell, it creates 2D output. You got digital surface model calculations, digital terrain model calculations, and yeah, there's a whole list of operations that it does.
Mm-hmm. And there is something about triangulation, as I see at the bottom. Team.
Yes. Yes.
Creates team from ODM vector database.
And once you produce it, you can use shading and Z color to take it out of that black and white sort of output and have shadings, and yeah, so you can have sort of, yeah, outputs like this by specifying your values and, yeah, the shading colors. And it also tells you the mandatory modules that you need to put in. So like in file is the file that you put in, out file is the file that you have to, like, this is mandatory. O format isn't mandatory, but if you want your data, your output to come out as GeoTIFF, you can put in a O format. So not everything is mandatory, and some are, and it identifies what is and what isn't, and it gives you a description, yeah. And it explains everything at the top.
I have another question regarding this. Well, first on the ODM, I found this kind of open Opals data management or manager.
Mm-hmm.
But I mean, this file format is open. Do you know the exact link somewhere? Because, for example, I found most of these modules quite well, not quite similar, but okay, highly related to what PDAL actually does. So, but I cannot find in PDAL kind of a reader writer for this file format. So that's why I'm asking if this can be made interacting with the other one.
About the ODM?
Yes, because for PDAL, it also has a lot of readers and writers.
Mm-hmm.
But here, I don't know if you have to go through an intermediate format like GLASS, which could be useful, could be not, but I don't know, because also, for example, for the last format, do you know up to which version this thing works with? I mean, I think the common one is 1.2 and the latest is 1.4 or something.
Mm-hmm.
Do you know by chance?
I don't think there's, it explains here, it should cover all LAS formats, all LAS files. So the formats that you can put in, import in, I think, I think is it. General description. I think, or are these all of the outputs you can have?
Okay.
I'm not too sure, but I can get back to you on that. So the in file has to be strip or LAS. So strip is, yeah. I've got to get back to you on that.
Okay, don't worry, don't worry. Okay. But I mean, the actual format, do you know if it's open or they have an open specification for it?
What is open, did you ask?
The file format, because I'm not sure if it's all open file. I see it somewhere.
ODM?
Yeah, but IDM is the data manager. I mean, it's kind of an intermediate format, I assume.
So, Nina, you have a question. Homework to investigate what is ODM.
It's a key component of Opals. It has been developed for efficient access to huge spatial data sets and for handling arbitrary attributes capsulated to geometry objects. They're very tricky questions. I'll have to get back to you on that.
Don't worry, it's highly technical.
Apparently they maintain also special data index.
Yeah.
Yeah, it's really, you notice it, Joseph, but it's a data manager, yeah.
Special index. Okay, that looks interesting.
And even there is some predefined attributes.
Yeah.
But anyhow, I think that this is an interesting kind of open, it's not open source, but open freeware software, which can be used at certain degree. And the group in Vienna is really, Vienna Technical University is really a very good group. Exactly what Nina mentioned, they're busy already for years with processing point clouds and specifically creating terrains, filtering all kind of data above the terrain and extracting high quality terrain model. So it's, it's interesting for some of you to have a look at it.
And they also have a module here for, where is it? ICP.
For co-registration.
Yeah.
That's
and
good.
yeah, so if you're interested in that, I haven't used it. I'll be using it soon, so I can give you feedback on that.
Yeah, actually, in the new project that we are going to start with Max and Kalim, this might be needed. Mitko, could you say something about it? Because you already did co-registration. Is it going to be needed for the project, or you have already the tool?
Well, I haven't co-registered on the previous scans that we did. And it is very good if you need to try with this software. I know that roughly can be done with Cloud Compare, but if this can be done automatically, where you can put the scans and everything is done.
Yeah, so for everybody, co-registration is when you have scans from different position of the scanner, and you have to combine everything in a bigger point cloud. So you have to identify how the different scans link to each other. And this process is called registration, co-registration. And there are all kind of different algorithms for this. And software packages have these algorithms implemented. And Mitko mentioned Cloud Compare, and apparently, this Opals also has kind of have the ICP, the algorithm that makes the co-registration of the point clouds.
There are many libraries. I know a few in Python that also do ICP, and but let's see. Let's see if the results are good. I will provide another scan very soon to you, and just to see if this can will be better. And yes, it is interesting to see.
Yeah. So I have to go to another call. So I have to leave. But in a way, you can continue talking if you like. If you have some more questions, if you don't have questions, yeah, I can imagine that you also want to go. And we can close the meeting in general. So it's up to you. Does somebody want have some questions?
I wanted to say something. If you do have questions, you can email them to me, and especially on ODM, on Opals, and I can get back to you if you are interested in using it. And yeah.
Well, excellent. Look, thanks, Nina. That was a really good presentation and a good way to share some ideas with the inaugural meeting of our group. Thanks, Sissy. I know you've got to leave, so please.
Yeah.
Yeah. Thanks so far, and we'll see you at the next.
Thank you, everybody, and okay, we'll see each other again after 2 weeks. And I discussed with Harshit because now he's comparing 4 or 5 freeware software for creating point clouds from drones. And I asked him to prepare something for the next time. Next time we'll have, I hope, more time for discussion because we know already ourselves, and by this time probably Sadman will be ready with the overview of everybody's skills, research topics, and so forth. So no need of introduction. We immediately can start and see what Harshit is going to tell us, and also start immediately with the discussion.
Okay. Cool. Well, thanks. Are there any questions? Sissy needs to leave, so thanks, Sissy.
Yeah, I'm leaving. Nice. Yes, I really have to.
Yep. And look, thanks.
Bye, everybody.
Bye.
Bye. See you next time. Bye.
Bye.
Thank you.
Thank you. Bye.
Thank you.
Okay. Well, unless there are any other questions, you're welcome to ask questions for Nina or make some comments. Anyone? Okay. Well, let's formally conclude our inaugural Point Cloud session. So, look, thanks everyone for joining. It's been really good having so many people online. We had 19 or 20 people, I think. And so it's been a very good session, and I'm really looking forward to continuing these for the next few weeks and months. And you know, it's a lot to talk about. So thank you everyone for joining. Yeah. And you should all, any admin questions, please just send them at me. I've got the calendar invites on an automatic little thing, and apologies whenever I make a change, it seems to email everyone, but just accept it and delete it. So okay. Look,
thank you, Jack.
Yeah, thanks, Nick. And we'll see you guys all soon.
Yes.
Okay.
See you.
Okay.
See you guys.
Thank you. Bye. Thank you. Thank you.
Yeah.
Thank you. Bye.